Hello, Algebra 1 students. Welcome to our first day of notes. This is Miss Berniska here, and I am going to provide an instructional video on day 1 notes. So our learning targets for day 1 is I can solve a multi-step equation and justify each step, and we'll explain what that means. And also, by the end of these notes or learning, you should also be able to translate a word problem into an equation. So this whole unit, we have two big goals. Our first one is to solve equations, and our second one is to solve inequalities. So we're first starting with solving a multi-step equation, which should sound familiar. These are skills you have learned before. So the big idea when we solve an equation is to isolate or solve for the variable, which is our unknown value, okay? And we're going to do that by following two quick steps. So when we solve a multi-step equation, the first thing we're always going to do is we're going to simplify one or both sides of the equation. And so I'll follow that below, and I'll follow example 1. So it says solve each equation and justify each circled problem. So step 1 says simplify one or both sides of the equation. So for here, when I say simplify, it means combine like terms. So in your notes right now, if you also want to make a note, simplify means to combine like terms. Okay? And like terms would be an example of like 2x and 5x, that's 7x. Or 2 plus 5 is 7. So in example 1a, when I combine those terms, I now have 9x plus 3 equals 12. Okay? Then the second step is to use inverse operations to isolate the variable. So let's review what inverse operations mean. So inverse operations, addition and subtraction are inverse operations of each other, as is multiplication. I'll use like an asterisk, and division are inverse operations of each other. So back to example 1a, I want to isolate the variable, so I'm going to subtract 3. So because it's a plus 3, I'm going to subtract 3 from both sides. And so now I have 9x equals 9, okay? Again, my goal is to isolate the variable here of x. So to do that, I have 9 times x, right? So the inverse operation of 9 times x is division. So I'm going to divide both sides by 9. 9 divided by 9 is 1, so we get x equals, and then over on the right, 9 divided by 9 is 1. So my final answer is x equals 1. Now, what does this mean? This means if I take a value of 1 and I plug it in wherever x is, so here's my check, 2 times 1 plus 7 times 1 plus 3, and we want to know, does that equal 12? So does 2 plus 7 plus 3 equal 12? You betcha. So when we solve an equation, it means we're finding the value that when I plug it back into the equation, I get a true statement. Okay? So you will also notice we want to justify each circled problem. So we're going to list the steps we did. So the first step we did is we combined like terms. Okay, the second step we did is we did inverse operations minus 3 on both sides. And then we did inverse operations divide by 9. For example 1b, we're going to follow the same steps. So step 1 says simplify one or both sides of the equation. So on example B, I see on my right side of the equation, I have a 2x and a positive 6x, which are like terms. 2 plus 6 is 8. So I have 10, I always do that, equals, now I'm going to combine those two and get 8x minus 8. So again, I have variables on both sides. I would always recommend move the variables to the left, constants to the right. And I mean left of the equal sign and right of the equal sign. So we're going to use inverse operations. So again, my first step was I combined like terms. Okay, and I'm going to zoom in here. Now what I'm going to do is I'm going to move my variables to the left side by using inverse operations. So I'm going to subtract 8x left side. Now when I do this, notice I can't combine the 10 minus the 8x, so it's just going to be 10 minus 8x equals negative 8. Okay, so again, I did inverse operations minus 8x to both sides. I need my constants, which are my numbers without the variables, on the right side. So I have a positive 10. I need to move it to the right side, so I'm going to subtract 10. So this term carries down, so I have negative 8x equals negative 18. So again, inverse operation, subtracted 10 from both sides to balance it. And then I need to isolate my variable, so I'm going to divide both sides. So again, it's negative 8 times x. The inverse operation of multiplication is division. So again, notice IO divide by negative 8. Okay. So again, think about this. If negative 8 divided by negative 8 is 1. Our goal is to get the leading coefficient to be 1. So now I get x equals, and I have negative 18 divided by negative 8. Okay? We are always reducing our fraction, and we get 9/4 as our final answer. Now, I would accept 2.25 because it's an exact value. Okay? Those with a graphing calculator, you can type 9/4 in. Then you can hit the math key. And then you can hit number 1, which is math frac. And what that will do is it'll always reduce the fraction for you. And you'll notice it's going to spit out 9/4 again, because 9/4 is the final answer. So that's the big idea of how to solve a multi-step equation. We're always going to follow these 2 steps. Step 1 is we're going to simplify one or both sides of the equation. Step 2 is we're going to use inverse operations to isolate the variable, and it can be multiple times. Notice on example 1b, we use inverse operation 3 times to isolate our variable of x. There are now 4 other problems left in the notes. What I'm going to do is I'm going to pause the video. I'm going to complete the work. So you can pause as well. You can try to complete C, D, E, and F, and then unpause the video when you're ready to check your answers. Okay, I do want to bring your attention to example E. Now notice it is highlighted, so we are going to list our steps. So the first step I did is to move the variables to the left, constants to the right, is I did an inverse operation of +5 to both sides. Okay, now the next step is what looks a little different. So I have the quantity of 2/3 times x equals 8. And we can go about this 2 ways, because 2/3 times x, the inverse operation of multiplication, is division. So option 1, I'm going to do it this way, is I can divide both sides, I should say each term, by 2/3. Okay. Okay. And in my calculator, I would The other method is when you have a fractional coefficient, such as 2/3 times x, is to multiply by the reciprocal. So the reciprocal of 2/3 is 3/2. So you can multiply like this, 3/2. And this way we would also get, remember we multiply fractions across, so we get 24/2, which eventually is x equals 12. So you can check your work for C, D, E, and F. Keep in mind on C, D, and F, it is important that we always combine our like terms first. Just on D and F. Notice in purple, we combine the 1x minus 4x, which is negative 3x. On F, we combine 2x minus 1/2x to 1.5, or 3/2.